Like that guy told you, I'm Scott Maher. I'm from Twilio. I'm a tech lead on the messaging team. How many of you guys read the actual description of my talk on Sked, whatever? That was a long description. There's no way I'm going to be able to talk about any of, well, all of that. It took me at least 20 minutes to read everything that I wrote. So I apologize if you expected me to put all of that in there. How many free monad tutorials have you been to at this conference? You got room for one more? Yeah? Okay, cool. I don't know if it's the free monad or free monads. How many people use it regularly or have? Okay, cool. I'm gonna assume that you have a little bit of familiarity with the free monad. I won't go into it in depth. The basic stuff, the tutorial stuff that you see online. Basically, the question that I've been trying to answer for myself is this really a reasonable way to build programs? Should I use it? Should I build services out of it? Is this practical, or is it kind of more academic? And the answer is, sure, why not? It actually is really, really useful, especially for programs that do a lot of I/O. Because I/O tends to unnecessarily confuse your business logic. So if you got one program that's mostly pure and then writes the output to a file at the end, I don't see a lot of utility in the free monad. But if you're building, say, a service in a service-oriented architecture, maybe you're talking to a database, you're doing like varied and multiple different types of RPC calls, maybe queues are involved, then this is really useful because when you're writing your tests, you don't really have to mock out that type of I/O. You can just write a testing interpreter for these actions and defer execution to another time or different implementations. So in the classic free monad examples that you see around, they're a little bit contrived. You would write your DSL, your grammar, which has your options that you would execute at another time. In this example, you've got a store with get, put, and delete. You've seen this before. You write some kind of a program that ultimately returns a free of store and whatever kind of result type that will eventually get interpreted by your interpreter. It kind of looks like this if your database lives entirely in memory. And this is problematic because you don't have a way of combining that DSL, that storage DSL, with other DSLs, with other grammars that you might actually use when realistically building complicated programs, right? And the whole point of the free monad is to make your program simpler. You can't break that into libraries. If you add more and more terms, your grammar does more things. Your interpreter's got to get bigger, monolithic. If you split your company into multiple teams, or if you work for a large organization, you're eventually going to want different people to be working on different parts of the grammar or focused on different domains. So you really need a way of not just building grammars and DSLs and that are expressed in terms of the free monad, but you need a way to sort of combine multiple different grammars together. So that's what the CoProduct's all about. You can see here, it's a type that you get from a lot of places. If you use Cats, you can get it from that. If you use Scala Z, you can get it from that. Shapeless has an implementation. And it's a way of saying, it's like a higher kinded either, really. It's a way of saying this thing could either be an F, which takes one type argument, or it could be a G, which takes another type argument. That can't be both. And the way you would apply it to your free monad program is you'd say, this step in the program is either this domain or that domain, or maybe it's this other thing. And you can use it for all kinds of different reasons. It's kind of, in the Cats vernacular, it's like an either K, because it's got that higher kind. So I'll take you through an example. Looking at blog post examples of code, looking at Tech Talk examples of code feels a little bit like flipping through a gallery of stock photos. You have this very general sort of case that you hope relates to somebody in some way. So I know this feels a little bit contrived, but it'll kind of make sense. Maybe your company is tasking you with building an art store. So you've got a domain of You got art. These are domain objects that you're selling, and you also maybe sell frames. And here's your grammar. You've got this inventory DSL, which allows a user to search on artists and returns a list of art. And you can also query the inventory for a list of frames that are available for sale. And maybe another team is working on more of the shopping cart functionality, or maybe this is something that you buy off the shelf from a third party. And you've got a grammar, you've got an algebra to describe all the things that you would normally do with a shopping cart, like add items to a cart and list your cart items and maybe make a new cart because you abandoned the old one. And then lastly, you've got some sort of e-commerce provider, potentially. The E stands for electronic. And you're using Stripe or PayPal or Braintree or something, and they give you a way to purchase items. So this is your grammar for talking about that, which has only got one member. Takes a card ID and some payment info. Apparently they only accept Bitcoins, and will give you back a receipt of some sort. So CoProduct was a little ways ago. Just a reminder, it's this thing that takes an F or a G, one or the other, and you would use it for your art store to combine together all these different grammars. And since it's only got two sides, you would first build up things two at a time. So since you've got three total grammars that you want to combine together, you start by combining the inventory of the cart. And then you would take that, you'd call that searching cart or something similar, and then you'd tack onto that the commerce part, which is your payment provider. And it would give you a type called rat store because you're bad at typing and you bought the domain and now it's just called rat store. And just to be super clear, this inventory, this cart, this commerce, these are all the types that represent your free grammars. These are the free of your abstract data type, algebraic data type. So we'll then create our smart constructors. And typically, in a lot of examples you see online, these are just aliases for free.liftc to lift your grammar into the free type. In this case, we're doing something a little bit different. Notice this class inventories. It's parameterized on F, and it takes an implicit of inject at the top. So first of all, you can see that these smart constructors, you have to instantiate them, which is kind of interesting. And the F in this case is supposed to represent another grammar that you want to work with. So for us, this might be a shopping cart, but it's not dictated. It's generic on F, whatever that might be. And you also expect a instance of inject to be provided to you. And we'll get to that shortly. And then the other thing to note here is that we use free inject instead of free liftc. And that is basically a way of using that type class that's passed down. If you are expecting your grammars to be used with other grammars, you kind of have to do this unless you have some other scheme for composing your grammars together. So it's kind of a planning ahead type thing. So the inject type class, I don't see a lot of use for it other than this situation, but I haven't looked at it in depth. Maybe somebody can tell me more. But in short, it's basically a way of taking an F and making a G, in some cases with the inject method. And sometimes, maybe, you can get an F out of a G. And that's what it's talking about. So there's a few notable instances of inject that you get for free out of the Cats library. Probably the same is true of the Scala Z free library as well. And other implementations of this because it's such a useful and common pattern. This basically allows you, this Cats free left inject, which is pre-baked into the system, helps you build up these CoProducts grammars from existing, from basically existing shapes up here. So it automatically allows you to go from an F to a coproduct of F and G, which in this case is our F might be like our commerce grammar, and our G is our combined commerce and shopping grammar, or our combined inventory and shopping grammar, however you sort of want to put these together. So kind of at the end of this, we then give ourselves a handy constructor here, which for actually, like I said in the beginning, we need to actually build an instance of our smart injectors. And this is our constructor for that with all of the implicits defined here. So we say, hey, I want to give you a instance of inventories, but you got to tell me what you want to mix me with. And it can be reflexive. It could be, I'm going to mix myself with myself in case you don't have any other grammars that you want to mix this in with. Makes it kind of sound like the cake pattern, huh? Here's the implicit of that, and then I'll give you a new inventories. So here's our DSL again, that's combined from these two different types, or these three different types. And then what's really, really cool is you just call this. You say, I want an inventories to be injected into rat store, coproduct implicits, free implicits, just sort of know how to build the structure up with the coproduct to actually inject inventories into that. And it's really, really neat. It's kind of beautiful how that works. So now it's time to actually write your program. In this case, I'm gonna build all my different grammars up here, the cart, the inventory, checkout. I'm gonna buy art for myself. So this type ends up being a rat store that ultimately gives me a receipt. I get some frames. I search for artist, Scott Maher. I got a lot of self-portraits, like to look at myself. Get a new cart, add my art to the cart, add a frame to a cart, and then check out and purchase, yielding my receipt. Can you spot the unsafe operations in this?
Yeah, there's a head.
Yeah, there's two heads. You just totally ruin everything. All this effort to be functional, and look what you've done. This is kind of what you expect, right? For this, you have one domain to one interpreter, kind of like as if you're just working in with one domain at a time, which is nice, right? In the previous slides, we talked about how you kind of, if you're building these grammars, you kind of need to expect that it's going to be injected into other grammars. Here, you have a checkout interpreter. I would never do this. Don't do this. The target monad is, it goes from commerce to ID. So you would do all your normal side effecty type stuff here, maybe. And then here's where we actually do the interpretation. So we're taking a command of type commerce. There's only one type of command here, which is purchase. But if you had a different interpreter, like for the shopping cart, you'd have like an add to cart, list items in a cart, new cart, different cases. And then you do the business logic here, which apparently I decided to write this as asyncs, eithers. So I got to wait for the result. Definitely would not do that. And speaking of that, in the real world, instead of having an object checkout interpreter, you'd probably have something that would give you some kind of dependency injection from it. So you'd have a class checkout interpreter, and maybe it takes a Stripe client that's a Java client under the hood or something like that, maybe some sort of thread pool. And you would probably go from commerce, which is your grammar, to something that's not ID. This is a good choice. It might just go directly from commerce to either T of future, where your error domain's kind of represented on the left side, and your desired result, which would be receipts, on the right side. That's a normal thing. You might mix in, you might build into your monad stack a writer T. You do all kinds of stuff. ID is not a realistic choice here. Putting your interpreters together can be a little tricky. So that was just one interpreter. That was the commerce interpreter, but you got many more. And to actually run your program, you're going to need to combine them all together, right? So here's that CoProduct. I think this is the last time, so if you didn't get it before. And we want a function that looks kind of like this, from rat store to ID, because that's what all of our interpreters are going to. And rat store really expands to this CoProduct, which kind of looks like a binary tree, right? You got commerce, and then at this layer on the right node, you got CoProduct again, which goes down to an inventory or a cart grammar. So our interpreters are function keys, which are another way of saying they're functions that operate on the higher kind of H and G, which are type constructors which take one argument. Kind of like CoProduct is on F and G, where F and G are type constructors that take one argument. Function K is kind of like that analog. So you get this apply, takes an F, and gives you back a G. And we also have a handy function on function K, which I probably should have just moved within these curly braces, called OR. And what OR gives you is it basically takes your function K and another function K, and it turns it into something that takes as an argument a CoProduct, which is kind of exactly what we were building up a couple of slides ago, right? This is actually what our grammar looks like. It's a CoProduct of multiple different types of grammars. So we've kind of got a way, based on what our interpreters are, which are function Ks, to combine them together. Now we just need to string them together in a way that kind of matches this rat store structure here. And it's really not that complicated. It's just do things in the correct order and you should be fine. So you start off with matching your inventory interpreter with your cart interpreter, and then you match that with your checkout interpreter, and then you ultimately end up with a function K that looks the way you want to actually apply your free to it. And now you can run through your program. All that work for this one line. It's kind of anticlimactic, isn't it? But there you go. Neat. I want to take a few moments to talk about how neat that really is. Functions that return functions are really, really cool. We're kind of used to this as an idea now, right? As functional programming, Scala people, OCaml, Haskell, whatever people, right? And really, you can make the argument that all multi-argument functions are really functions that take one argument and return another function. wxy to return a z is really a function that turns a w that returns an x to y to z, and so on and so forth. You kind of leveled up with this. You built not just a program or a function that returns more functions, you return programs that return more programs. Because programs, just like functions, are just values. And all that free is giving you is a structure that you can unpack step by step and evaluate step by step, right? A monad is a way of serializing things as steps and steps. And this is a way of serializing steps into a data structure. Really neat. And yeah, there's more functions. So assume that your art store is doing really, really well. Everybody's buying those self-portraits of Scott Maher. And you decide to buy the company down the street, which happens to have a 3D printing factory or something like that. And you decide, hey, I'm going to start selling 3D printed objects that people can buy through my website. Have you guys ever used like Shapeways or anything like that? Those are 3D printing on demand services. They're really neat. So I'm not a domain expert in 3D printing, but I assume this is what a algebra for 3D printing looks like. Maybe. Extrude, these all look pretty reasonable to me. And you can build these up and you can put these values anywhere because they are values, right? You don't have to interpret them anywhere. If you don't want to, you could actually have your other algebras return these programs, your other grammars return these programs somewhere. So, this is our inventory algebra again, and since we're adding new product lines, we're still selling the artists or the arts, we're still selling the frames, but now we allow you to 3D print a Venus de Milo, and you can choose how big you want it to be. That's an integer, so we only do meter increments, so you can't get a half meter. And since that function, that step, that part of your grammar returns a 3D printing program, you can do all kinds of things with it. You can interpret it right away. You could figure out how to serialize it in some way, push it on a queue, have somebody else deal with it, that kind of thing. You could just forget about it. You can do whatever you want, and that's neat. You really got to start thinking about these bigger structures as values, these programs that you can interpret as values, and do whatever you want with those values. So that's a neat concept. Now, getting back to what I was talking about before, is the free monad, or are free monads, is this a reasonable way to build programs? And yes, I think so. I think especially in highly networked environments, it's a very reasonable way, because the payoff, despite all that boilerplate, is that you can really reason about I/O in a more controlled manner. Realistically, your interpreters and grammars might have dependencies injected. I kind of pointed that out in the commerce example. If you have stuff that does database I/O, you might inject thread pools or like a slick client or something like that. And again, I mentioned earlier, but I want to reiterate, choose a good target monad. I like to use either T for a lot of things because since I live in a networked environment most of the time, I use futures a lot, and I also don't want to rely on the built-in exception handling there. But the mechanics of these free monads are terrible. There's so much boilerplate. Why is there a coproduct that makes me build a binary tree? And all this boilerplate can totally be generated with macros. Anyway, I just want to say thank you to all of the people who have worked so hard to put so much documentation out there about this stuff. The Cats tutorials, not just on the free monad, but on all the type classes and data structures, are amazing. Thank you so much for the work on that. Paul Types on Reddit Scala is really awesome and super friendly. Why the free monad isn't free, Kelly Robinson, I think, did that talk earlier to yesterday. I missed it, but it's also online. It's really good. And there's a ton of other resources out there. So that's it for my talk. Thank you very much for coming.